Hey guys, we are on to the second page. We did the first page already, so don't let this scare you. We've already done it. That was the first video. Now we're doing the multiplying polynomials, which is also parts of your notes page, but it's just page 2, so it looks like this. Again, this is the first video, and we're now doing page 2, multiplying polynomials notes. Okay, let me get my pencil. About to rock and roll, guys. You're gonna love this. You're gonna love multiplying polynomials. I know it. I just know it. Please excuse my dogs making weird noises. Girls. Hey, stop it. Okay. Let me find a good pencil, guys. Found two and some pretty pens. Okay, so we learned how to add and subtract polynomials in the last video. So right now we're going to be working on multiplying polynomials. As you can see, I have marked out FOIL method everywhere that it is on here. We're not going to be using the FOIL method. We're only going to use the box method. It just makes more sense when we get into multiplying trinomials and things like that. So we'll only be using, stop it girls, the box method. Okay? First of all, we're going to review the distributive property. So we've got one term right here, a monomial. Do I need to put y'all away? You're messing up my video. Okay. So we've got one term right here, and we want to multiply it by this trinomial, x2 minus 4x plus 2. And it wants us to use the distributive property. Now, just like when we did subtraction and we distributed the negative, we're going to distribute this term to each term that is behind it in the parentheses. So the negative 2x is going to visit this one, and this one. You have 3 terms, so negative 2x should visit 3 terms. Come on. Come on. I'll get my nerves. Okay, problem solved. Maybe now you can hear me. Alright, so negative 2x is going to be multiplied. Remember, we are multiplying by x squared. So, negative 2, remember there's an implied 1 before every variable that doesn't have a coefficient. So, negative 2 times positive 1 is negative 2. Now, don't forget your variables when you're multiplying. So, x times x squared is equal to x cubed, okay? That just means x times x times x. So we're going to put x cubed. Alright, so now the negative 2x has to visit the next term, which is a negative 4x. Negative 2 times negative 4 is a positive 8. Remember, when we have a negative times a negative, we always get a positive. So I'm going to go ahead and write the positive 8 down here. And then we go x times x. Well, x times x is x squared, right? So we do x squared. Now the negative 2 is going to visit the positive 2. There is no variable. This is just a constant number, positive 2. So negative 2 times positive 2. A negative times a positive makes a negative. 2 times 2 is 4. Okay? Now we have the x here. We don't have anything to multiply the variable by, so we just bring that x down. And bing, bang, boom! We just did the distributive property. Again, the term that's in front visits every term after. Don't forget, if you have a negative here, using the signs that are in front of your terms, okay? Don't forget that. Alright, now we're going to use the box method, no FOIL method, to do our first binomial times a binomial. Alright, so we've got x plus 3 times x minus 3. Now here's the thing about the box. It doesn't matter if you put the x plus 3 on the top or if you put the x plus 3 on the side. It's purely up to you. All of these terms are still going to be multiplied together whether you put one up here or one on the side, okay? X plus 3. Okay, now I've got x minus 3. Something that I like to do when I'm using the box method is instead of putting the subtraction sign here where I might miss it, I put it in front of the 3. That way, when I go to multiply this 3 by x and 3, I won't forget to put that negative in. So x times x, it's just like your multiplication chart. The two that line up together, that's where their answer goes. We already said x times x is x squared. Now we've got positive 3 times x. That's a positive 3x. Now we've got x times negative 3. That's a negative 3x. Now we've got negative 3 times positive 3. A negative times a positive is always a negative, and 3 times 3 is 9. All right, so our box is complete, but we've still got one more thing to do, and that is to add the like terms. Once your box is complete, you are done multiplying. Now you want to just add like terms so that you can write a nice, pretty answer. Remember, we are always going in standard form, so I want to start with my highest exponent first, x squared. Do you see anything like an x squared? I don't, so let's just pull it down. Okay, now we've got a positive 3x plus a negative 3x, and we know that any positive number that is added by its negative counterpart is 0, okay? They're both the same place away from the number line, so when they meet up, they're meeting at 0. So 3x plus negative 3x is 0. The x's and everything cancel each other out, okay? So we don't have to worry about that. Woohoo! Now, we've just got this little minus 9 hanging out, little negative 9. So that's our answer. X squared minus 9. Pretty simple stuff. Okay, on to number 7. We're going to use the box method. Do not use the FOIL method. Okay, so we've got this binomial times this binomial. Well, I'm going to do it the same way. Well, I'm going to do it the different way. So I'm going to put the 2x and the negative 4 right here. And I'm going to put the 3x and the negative 1 here. Just to show you it doesn't matter. You're going to get the same answer. Okay? 2x times 3x. Remember, this one times this one goes in this box. 3 times 2 is 6. X times x is x squared. Okay? Now we've got negative 4 times 3x. Negative 4 times 3 is negative 12. Remember, negative times a positive. And then we're just going to pull our little x over here. Right? Now we've got negative 4 times negative 1 coming right here to this box. I'm just kind of going around clockwise. So negative 4 times negative 1 is a positive 4. Remember, a negative times a negative makes a positive. Now we've got 2x times negative 1. That makes negative 2. Bring our x down. All right. Next thing we do, we add like terms. Our box is done. Time to add like terms and simplify our answer. This answer is correct, but we need to simplify it. Okay? So you may have a multiple choice question, and it may have 6x squared minus 2x minus 12x plus 4. Just pulling everything out of the box there, guys. 4 different terms. But this is not correct. Okay? What is correct is the simplified answer. Just like fractions, we got to simplify these polynomials. Because math is hard enough, so let's make it simpler. Right? 6x squared minus 14x. Because negative 2 plus negative 12 is negative 14. And then we just pull our x down. Remember, when we're adding, we don't make the variables higher. Okay, we don't exponent them like we do when we multiply. So we just bring the x down, and then we do plus 4, our constant. This is the correct answer because it is simplified and there are no like terms. Okay. Find the area of the rectangle. Okay, so Hopefully, you know the formula for area, but if you don't, I'll go ahead and let you know. It's length times width. So in this rectangle, the length is equal to 7x plus 10, and the width is equal to 4x plus 8. Now, if we're just multiplying length times width, and that's how we get the area, well, shoot, that's easy. We're going to do 7x plus 10 times 4x plus 8. Boom. And that's going to give us our area. Well, look at this nice little setup we've already got. Check it out. We can just make a little box right here. And I'm just going to put the 4x and the positive 8 over here. And then just kind of scribble that out a little bit so I don't get confused. And we'll go ahead and erase the length. Alright, so we've got 7x times 4x. 7 times 4 is 28. X times x is x squared. 4 times 10 is 40x. 4x times 10 is 40x. 10 times 8 is 80. 7x times 8, okay, so 8 times 7 is 56. Easy way to remember that is 5, 6, 7, 8. Okay, so 8 times 7 is 56. No variable times x is x. All right, so now we got to add like terms. I'm going to bring my highest exponent down first. That's 28x squared. I know that these two guys are like terms, so I'm going to go ahead and add them so I don't have to just write extra stuff. So 40 plus 56 is 96. So we're going to do a positive, I hate when that happens, positive 96 x plus 80. And there's your answer. Nice and simplified. And there are different terms. They are in descending order. This is in standard form already, so we don't have to switch it around. It's lovely. Okay, now we got to find the volume. Oh snap. So the formula for volume is the length times width and times the height. Okay, so when you're working with the volume, you're going to be doing times height as well. So let's think about how to do this. Now we've got 3, well, but we've only been doing 2. So what do? Well, let's just start with x plus 6 and x plus 3. We know how to do a box method like that. So let's go ahead and draw our box and get the length times the width. And then we can multiply the length times the width times the height. Or no, we're doing the length times the height, and then we'll multiply by the width. The width is x. Doesn't matter, we just have to multiply all 3. Okay, so x plus 6 and x plus 3. We're going to go ahead and do our little box here. X times x is x squared. 6 times x is 6x. 3 times x is 3x. 3 times 6 is 18x. Okay, let's go ahead and pull that polynomial out of the box. X squared. 6x plus 3x is 9x and 18. So we just do plus 18. Well, we still gotta multiply by this little guy. So let's do this. We're gonna multiply that entire trinomial by the x. Distributive property. X times x squared is x to the 3rd power. X times 9x is positive 9x squared. And x times 18 is positive 18x. And there you go. You got a volume. Beautiful. Moving on. Alright, so now we've got 3x plus 5. This is just the same thing that we're doing right here. We're about to get a little more technical, so let's enjoy these two binomials while we can. Alright, so we're going 3x plus 5, x cubed, 4x. So, don't forget, we've got x times x to the 3rd power right here times 3x. That's going to be 3x quadrupled. guess you could say. To the fourth power is a quintic. So that's a quintic now. 5 times x to the third power is 5x 3. 3x times 4x is 12x squared. 5 times 4 is 20. Bring that x over. Now let's pull it out of the box. 3x to the fourth power is the highest. Okay, these two, well, no, they're not. They're not like terms, because 5 times x to the third power and 3x times 4x is x to the second power. So we don't have any like terms, so we're doing plus 5x third because it's the next highest. Then we're doing 12x squared because it's the next highest. And we're doing 20x. No! So that's your answer. It's pretty long, and that's what some of you don't like about simplifying polynomials, adding and multiplying, is you don't get a nice like one number. It's just going to be as far down as you can get it, which this one, it had all different exponents, so we didn't have any like terms. So it's a pretty long answer, that one is. All right, so, whoa, whoa, whoa. We got a binomial times a trinomial. Man, we have not done that yet. Never fear, I'm here, okay? We're just gonna use the distributive property, okay? We're just gonna use the distributive property. This one term visits all of these. Well, guess what? Now we've got two different terms visiting each one of these, all right? And then we're gonna add everything together. So, first thing we're gonna do, 2x times x to the fourth power is 2x to the fifth power, okay? X times x to the fourth power makes x to the fifth power. Basically what you're doing when you multiply these variables is just adding the exponents, okay? All right, now we do 2x to negative 6x, so positive 2 times negative 6 is negative 12. X times x is x squared. And we've got 2x times 3. 2 times 3 is 6. And nothing to multiply that variable by, so we just bring it down. All right, good job. Gotta go one more time. One more time. We still have this positive 1 left over, so let's have the positive 1 visit x4. 1 times x to the fourth power is just that, x to the fourth power. 1 times anything is itself. Positive 1 times negative 6 is negative 6x. So positive times a negative. Okay, and then the 1 is going to visit the 3. Positive 1 times positive 3 is positive 3. Looking pretty good, looking pretty good. I see 2 like terms, actually. I see this positive 6x. And I see this negative 6x. Well, what's a positive plus a negative? That is the same number. That's 0. So guess what? Bye-bye. They canceled each other out. Positive 6 plus negative 6 is 0. So just get rid of those. Don't even need them. Now let's go in order. 2x to the fifth power is first. Second is x to the fourth power. Third is negative 12x squared. And the last one is positive 3. We are in lowest terms. We are in standard form. Very good. So the answer for number 11 is 2x to the fifth power plus x to the fourth power minus 12x squared plus 3. Yay! All right, so now we've got, it's going to start getting a little longer because we're starting to have longer stuff. So the way that this one is written, we've got the trinomial before the binomial. When we're doing the distributive property, just to make kind of less work, I want the term that is smaller before. So we don't have to go 3 times and do the distributive property. Now we only have to go 2 times and do the distributive property. So all I'm doing is switching those around, and we know that that's the commutative property of multiplication. Doesn't matter if you have 4 times 6 or 6 times 4. It's the same thing. Just like in these trinomial times this binomial, if we switch them around, it's the same thing, okay? So don't be alarmed. Minus 6. Now we're going to have 10x visit each term. 10x times 2x squared. 10 times 2 is 20. X times x squared is x cubed. And 10x is going to visit just the x. 10x times x is positive 10x squared. 10x times negative 6. All right, so now we got 10 times negative 6. That's negative 60. And then we are just going to bring our x over because this is constant, so we don't have to figure out x's exponent there. We just bring it on down. Okay. Next term. 4 times 2x squared is 4 times 2 is 8. That's a positive 8. And x squared, because 4 is a constant, so we don't change the power of the variable. 4 times x is 4x. 4 times negative 6 is 24. And that's a negative 24 because we've got a positive times a negative. Alright, so it looks like both of our terms have went and visited each term in the trinomial. So let's go ahead and do like terms. Let's see. I see 10x squared, positive 10x squared, and positive 8x squared. Those are alike. And I see negative 60x and positive 4x. Those are alike. Okay, so let's go ahead and add those up. Remember, we want to do it in standard form now. So we take our highest exponent, which is 20x to the third power, and we just bring that on down because there are no like terms for us to add up. Now we're going to do positive 10x squared plus positive 8x squared, which is positive 18x squared. Now we're going to do negative 60x plus 4x. Now negative 60 plus 4 now makes a negative 56. Okay? So negative 56x. Remember, we're not messing with the exponents when we're adding. We only do that when we multiply. Alright, so I've got all my like terms combined. Don't forget your little constant. Little baby constant. So this is your correct answer. It's in standard form and it is simplified. 20x to the third power plus 18x squared minus 56x minus 24. Dun, 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 dun. One more time. Trinomial times a trinomial. Alright, that means we're going to have to do this derivative property 3 times. We don't have a binomial this time, so we just got to do what we got to do. It's going to be long and tedious, but don't look at it and give up. Just go for it. Just dive in. Once you start, you know, just keep going. Just keep going. Just keep swimming. Okay. Negative 3 times positive times positive. Oh my gosh. Sorry. Start over. Negative 3 cubed times cut. All right, number 13, negative x cubed times positive x cubed. A negative times a positive makes a negative. X cubed times x cubed is x to the 6th power. Okay, remember we're just going to add these little exponents together. All right, so that guy's visited that guy. Great. Now, negative x3 times positive 3x squared. Negative times a positive makes a negative. Negative 1 times positive 3 is a negative 3. X cubed times x squared is x to the 5th power. Okay? One more to visit, x3, and then we're done with you. Negative x3 times a positive 2 makes a negative 2, because positive 2 times negative 1 is negative 2. I don't like that negative sign. equal sign. All right, and then we're just going to bring the x cubed over. Yay. All right, bye-bye. All right, now we've got negative x squared. It's got to visit everybody. So I've got negative x squared times x to the third power. That's negative x to the fifth power. I've got negative x2 times positive 3x2. So a negative times a positive makes a negative 3x squared times x squared is x to the fourth power. Okay. Now we've got one more for him to visit. Negative x2 times positive 2 is negative 2x squared. Okay. Done with you. It's going to keep on going, man. Plus 2x. Because positive 2 times x to the third power is just 2x to the third power. I'm going to start using room down here because I don't want to go past this little point right here. Alright, so 2 times 3x squared, that's a positive times a positive, so of course that's going to be positive. 2 times 3 is 6, x squared. Okay, now we've got 2 times 2. That was an easy one, that's 4. Alright, now it's time to start talking about like terms. Every one of these terms in front have visited every one of these terms in the back. Okay? Let's see. So I've got a negative 8 to the 6th power. I don't see anything else to the 6th power. So that guy's going to be on his own, I'm thinking. Negative 3x to the 5th power. Negative x to the 5th power. Any more x to the 5th power? No. Okay, so I'm going to bring down this guy. Negative 8 to the 6th power. And then I'm going to add these two together. That's going to be negative 4x to the 5th power. And I'm done with them and them. Okay. Next in line, and I know you see this negative 2x3 here, but next in line is x to the 4th power. Remember, we're going in order. We're doing standard form. I don't see another x to the 4th power. It's all by himself. So we're just going to bring him down. Negative 3x4. Done with that one. Okay, now we're moving on to x to the 3rd power. So we've got negative x to the 3rd power. And we've got a positive 2x to the 3rd power over here. Those are the only two I see. So a negative 2 and a positive 2. Oh, snap. That's a 0. So x3 just canceled itself out. You ain't got to bring nothing down. Okay, now we're going to do x squared. So the like terms that we have are a negative 2x squared and a positive 6x squared. So that makes a positive 4x squared. Okay. Got positive 4 right there. No like terms. So we bring it down. And it's beautiful. It's already in standard form, so we don't have to switch anything around. Our answer, believe it or not, this is simplified, is negative x to the 6th power minus 4x to the 5th power minus 3x to the 4th power plus 4x to the 2nd power plus 4. Okay? So in a nutshell, that is multiplying polynomials. Now, you may be saying, why do we have to do this? Why do we have polynomials? Well, a lot of times in Earth, okay, science, whatever, there are a lot of unknowns. Okay, we know that things are unknown. So we use polynomials to figure out what that x might be. And once we simplify it, we will have the answers to unknowns that we don't know about. And this is going really deep, like into physics and geology and things like that. So they'll use polynomials to kind of predict what would be on the ocean floor, predict what would be, you know, 100 miles towards the core of the earth. Like we use these types of things to figure out unknowns, because at the end of the day, these polynomials are just ways to manipulate unknowns. And sometimes we can manipulate them enough where we get the answer. Right now, we're in Algebra 1, so we're just going to simplify a polynomial and we're done. But the things that scientists and people do with statistical data and things like that, the things that people do with these polynomials is quite amazing. So I hope you guys enjoyed this beautiful video that I made, and have a wonderful rest of your day, sweet children. But see, it gets awkward because, you know, I got to turn off the thing. So you have to turn it off, so.